Okay, so as already mentioned, our paper is about emptying, so like basically stealing energy from parked vehicles. It is a joint effort with Dominik, Kevin, and my supervisor, Mr. Hof. So maybe a short question. It's hard to see, but who here owns an electric vehicle? Some? Okay, perfect. And who here like has visited a charging station? Maybe something like this, like a fast charging station. Okay. Maybe with not your own, but from somebody else's vehicle. Okay, that's already a good quote. So if you're from Europe, you might have seen a plug like this. I think some parts of the globe also have the same plug. It's I think in Korea you also have the same. So this is what we use for charging. If you're from here, from the US, you might have one of the two left ones. So this is the old one, this is the Tesla connector, the North American charging standard. And then this is more for China, Japan, and this is for trucks, the upcoming one. But the interesting part that all of these, like the three ones on the left and the two in Europe, they all use the same communication protocol. So this all applies to them. Also what we just heard also applies to all of them, but not for, to the Chinese and Japanese ones. Anyways, so as I already said, our idea is we want to do something like this, right? In the past, this was very easy. You can just go up to a tank, maybe drill a hole in there, or just like open the thing and then like steal the fuel. But now with a battery, it's not that easy, right? Because you need to somehow access the power from the battery. And I think yesterday there was a talk about AC charging, and in fact, so AC charging. Already mentioned there is not much research about that, and the reason is simple. It's kind of the boring charging, at least from my perspective, but maybe I'm a bit on one side here. So the idea is in AC charging, basically you have a very limited communication, but mainly you like supply AC energy, and then in the car you have a converter which converts AC to DC power, because in the end you always want to charge your vehicle battery, and this vehicle battery is always DC. So you always need to supply DC to this battery in order to charge it. And yeah, so if you're charging AC, you're in fact always charging DC, just you have like a conversion in your car. And with DC, it looks a bit different, and this is where the interesting part starts, because in DC charging, you still have this communication, and we will look at what this looks like in a minute. But the interesting part here is that with a DC charging station, you have this direct access to the battery. So basically, there's nothing in between the vehicle battery and your charging connector, which would stop you from, for example, instead of charging the battery, discharging the battery. And that's exactly our idea. But before we go into this, 2 slides about how the charging stuff works. So you might have seen something like this, these different layers. It's like the basic computer science stuff, right? And charging communication, they in the end they are also based on IPv6 and TCP. So this is common tech that you probably know about, but they have some weird decisions. For example, here they use home plug, and then here they have some proprietary stuff. Whoever knows why they did that. But in general, it's like a very accessible thing. So you can like pull up Wireshark, look at the communication, stuff like that. I mean, for this power line stuff, you need some specific hardware, but it's doable, right? And then, so this is the basic process. We don't want to go over all of the details, but the idea is that like you start here, this is the stuff which is actually shared with AC charging. So if you do AC charging, you only have this very first box. Then you have a few handshaking things. Then this is what Tim just talked about. You have the payment authentication. And then at the end, when you pass all this, you reach the main charge loop. And the idea behind the main charge loop is that the car says, please give me 350 volts, DC of course, and don't give me more than 100 amps. And then the charging station says, okay, you are at 350 volts, but I'm only giving you 80 amps because I can't do more, I'm sorry. And this is like, this goes back and forth all the time. This is the main charge loop. So as soon as like all of this initialization at the top is done, you basically just do this all the time. So now I already mentioned we wanted to do like drain energy, but for that we need to have like a charging station, something we can use to interface with the car. something which we can use to go through these states we just looked at and reach this main charge loop. Because only when we reach this main charge loop, we will have access to the car battery. And we built this, we call it Dr. Kunigunde. It's just a joke name because the initials are DC. That's why we gave it that name. And basically it's consisting of two major components up here. And at the top you can see it's like a lab power supply, like you might have in your experimental labs. But the difference is the ones you probably have, they can do like 60 volts or something. And this one can go up to 1000 volts. So basically we use this to supply power to the car and behave like a real charging station. And the interesting part about this one, it can not only like supply energy, but it can also drain energy. And then down here we just have some banana sockets and some communication is behind this wall, which is not visible here, which we use to talk to the car basically. And then, of course, we also need to interface with the car. So we have this funky little connector, which basically adapts the CCS plug, which is at the front, to like banana sockets again. So we can make some interesting connections and also like quickly connect a multimeter and check the voltages and stuff like that. Of course, we also need the software to talk to the car and everything. And this is actually open source. You can look at it on GitHub. It's based on, of course, we didn't write all of this ourselves. So it's based on many open source projects like the EcoG ISO 15118 stack. And then we just added our interfaces to our power supply and so on to actually make it work, like talk to the car, talk to the power supply, supply voltage, all this kind of things. And like putting all of this together, like the laptop running the software, the hardware interfacing, we were actually able to like behave like a charging station, talk to the car, tell it, okay, we are now, we want to charge you. Please allow us, like give us access to your battery. And then once we have access, we can do whatever we want, right? We have direct access to the battery, we can charge it, we can also discharge it. And our question was, what would happen if we like start discharging? Will the car prevent us from doing so? Will it like stop? Will it complain? Will it maybe just does nothing? And this was like the idea behind our paper. And of course, we like defined a list of tests what we want to do, and like we want to do just try basic charging. We want to do maybe try to test if it supports only this -2 standard version. Maybe it supports only -20 version. Maybe it supports the own DIN spec. And of course, we also want to do discharging and so on. So we like defined a list of tests which we want to run, and then like do some automation so we can basically like plug in a vehicle and then run the script and then like tests all of these different aspects. Can I charge? Can I discharge? What happens when I discharge? Does it support plug and charge, what Tim just talked about? Does it support TLS for encryption and so on? This is all stuff we wanted to test. But then we had another problem, of course, because I mean, we have one electric vehicle in our lab, but testing with one vehicle is kind of boring. You want like a larger data set, you want more vehicles to test. And when Jeremy earlier gave a talk where he said they have like a tested with 50 drivers, I was like, wow, okay, that's quite a lot. That must be like a lot of work to get into that. And I mean, with cars, it's also hard to get all of these cars and like do tests with them. But luckily for us, we have a partner company called FSD. It's German for Fahrzeugsystemdaten GmbH. And basically what they do is they make the rules on how TÜV and DEKRA, how they make like the regular checks on your car. And they have like a big parking lot where they have a lot of different cars. And where they basically, when a new feature comes out from one vendor, they buy this car, look how it works, what it does, how can it be checked, can it break, what happens when it breaks, would it be like a safety issue, do we need to check this on a regular maintenance schedule, stuff like that. That's what they do. And because they have such a huge like car park, we asked them, hey, could we go around your park and like plug in our shady charging station into all of your cars? And they were like, yeah, okay, come by. So we were very happy. And then so the idea was we just tested a lot of vehicles, this Volkswagen ID.3, and I have a lot of pictures here. We'll just quickly skip through these. Some of them are even labeled, so they have their like branding on there. Also like from different manufacturers. I think this is an Opel, like a Stellantis car. This is a Hyundai. It's like a Korean car. Also Volkswagen. This is actually one of the cars of my colleagues. It's in our lab. We also tested there. And interesting here, you can see it was like the battery at this point was at 317 volts, and we discharged it with 3.7 amps. So this is always like the stuff we are doing. Like we're doing with each of these cars, we did this procedure of like these different tests. And then at some point, even the FSD ran out of cars. So this is my neighbor's car, this is my own car, and so on. And so what we ended up with, sadly, not 50 different ones, but I would say for when you need to acquire these vehicles, it's like not that easy. So an okay number of different vehicles where we tested like which standards do they support, what voltages do they have. Can I skip the pre-charge step, or do I actually have to do it? Can I discharge it? What happens if I discharge it, and so on? And actually, what we found is that the Volkswagen vehicles, they are pretty angry about you discharging them. So when they see you discharging for more than 60 seconds, they just like terminate the session. And like I said, in theory you have direct access to the battery, but ultimately the car has like a contactor, and it can just like disconnect the battery from whatever you're doing. So they do this. Tesla also does this, but not like after some time, but like after you've drained a significant amount of energy. So basically, I think this sums up to like 5 kilowatt hours. So once you drained like 5 kilowatt hours, the Tesla is like, yeah, okay, there's something shady going on here. But funnily enough, you can just like restart the charging session and then like to continue discharging once more, basically. And like with the others, we didn't have any problems. So with the others, we could all discharge them, basically. And then there's the sad row with BMW vehicles down here. For some reason, we couldn't get them to work. They didn't, like, not any of the tests, like not even the charging worked. They wouldn't go beyond pre-charging, and we don't know really yet why that is. We even know some people at BMW and talk to them, but when we had to hand in the final paper, we hadn't fixed that yet. So, yeah. But this is my last slide. Thanks for listening, and I'm happy to take any questions.